quadratic number patterns needs to have like this little spider webs coming down here. So the question says, first find me the general term. So when you see a question, I ask for a general term, or find the term for the nth term. Find a formula for the nth term. It can be any of those words. You've got to realize you're looking for Tn, an squared plus bn plus c. So the technique is, you look at those spider webs, you're going to go and look at the first differences, where you say 3 minus 3 is 0, 4 minus 3 is 1, and 6 minus 4 is 2. But it's always the second one minus the first one, third minus the second, fourth minus the third, etc. Then to get, that's my first differences. Then to get to my second differences, I say second minus the first is 1, the third minus the fifth. It seems so silly, but when we get to the x's, it's very important. So that would be my second difference. And then I know that it is a quadratic number pattern because the first differences are the same. But they in any case told me that it was quadratic. So if they are the same, then I know that the formula with the A, B, and the C works with these formulas that you must know of by heart now. 2A equals 3A plus B, A plus B plus C equal to, and I've circled the first ones in, nothing else. First ones, it doesn't matter here because they're all going to be 1, but always the first one. So then 2A is going to be equal to 1, A works out to a half. 3A plus B is equal to 0, but now you know from the previous one that A is a half, so it works out to negative 3 over. To remember that this is multiplication. Then, when I go back to A plus B plus C, I substitute the A and the B that I've got, working out to negative 1, becoming a positive 1, so that the answer is 4. So that my C value is 4. So I've got A, B, C substituted back, and I've got a quadratic number pattern. Interesting say. I think we said it already, but let me just repeat. Can the C be 0?
Yes.
Yeah. Can the B be 0?
No.
Yeah. Then it just means that that graph is symmetrical around the y-axis. If B is 0, then it didn't make any shifts so that the axis of symmetry moved. Can the A be 0?
No.
Why not? Because then it's not quadratic anymore. For a quadratic number pattern to be a quadratic number pattern, it's got to have an A. Otherwise, it's not quadratic anymore. Okay. Let's have a look at the second question. Ask me for term 100. So whatever you got here, it just means you've got to substitute the n with a 100 in both places and work out your answer. Think about it. If you maybe make a mistake somewhere, maybe even here you made a mistake and you put it in there. Could there possibly in this term be a fraction in this number pattern? Look at the number pattern. It's going plus 1, plus 2, 1, plus 1, plus 2, plus 3, plus 4. Will there somehow be a number? Those are not, I don't have any fractions. I'm not adding any fractions. So could there be a term that has a fraction here? Are you with me? Think about the logic. So maybe now you made a mistake here and it didn't work out correctly. So then this will be a problem. Are you with me? But then you're figuring out and thinking, I don't know where my mistake is, then tough. If you maybe made a mistake working out B, but according to your correct operations further on, I can still give you marks. Maybe then over here, if you got the answer as 4854,6, you would have said, but it's impossible because this thing doesn't have any fractions. So at least I see what you've done there. You don't know what the mistake is, but you know that there is a mistake. That could be in your favor. Then lastly, they asked me, if TK is equal to 94. TK, what's TK? Term number K is 94. Then determine what is K. Why didn't they just leave it in? Well, they didn't. So it's actually take the term number, but in terms of K. So this is a general term for N, the nth term. Now I'm looking at the kth term. So it's just in terms of K. Even if you left this with N's, it wouldn't have been a major problem. But they're asking you for K, so let's do the stuff right. So in terms of K equal to 94. Now, to solve this equation, it's definitely quadratic. So there's a few rules coming into play here. What did man do there? I time the whole thing by 2 because it's an equation. I can do whatever I like. Why would I want to get times with 2? What happened here? So that this is not a fraction anymore. Not so that it can be 1, but just so it's not a fraction. But couldn't I have first realized it's quadratic and said, well, ma'am always says get it equal to 0, first get the equal to 0. Okay, alternative techniques, steps, that's fine. So somewhere, somehow you had to get 0. But then also you had to do the techniques of knowing that I don't want the fractions there, because now I've taught you that you can use the fancy news calculator that will give you the factors, and immediately you can go get to your answers at the bottom. So if you want that, this has to be no fractions. So somehow, somewhere you had to go do no fractions and get it equal to 0 for a mark. Then, I've taught you now that in the calculator, when you punch in A's value 1, B's value -3, C's value -180, punch it in, and you put it into your calculator, it'll tell you that X, because it doesn't have a K, X1 is 15 and X2 is -12. It didn't give you the factors like that. You've got to now go back and say, so then K minus 15 would have had to be the first bracket and K plus 12, the second one, so that when I do my deduction, it got to the answer that the calculator gave me. Please tell me why that's not applicable. Because K is the position number. I asked you which number in the term is 90, or it can't be a position number 12 in the athletics team after the marathon. Somebody placed -12. Okay. Again, this one asks, what is the general term, or find me the rule for finding each term in this sequence. So if they didn't say that this was quadratic, I had a problem with it. How can I say that this is without a doubt a quadratic pattern? You can only say that if you can see that there's a constant second difference. So if I look at the first difference, it'll be -1, -3 is -4, right? 2 minus -1 will be 2 plus 1, which is 3. No problem with that. Careful, it's not 2 minus 1, which is 2. It's the third one minus the second one. So minus and minus becomes a plus, and 2 plus 1 is 3. Then, if I say the second minus the first one, it will be 3 minus minus will become a plus, answer 7. How can I, without a doubt, say that this is quadratic? You can't. You can't. But they told you that this is a quadratic number pattern. Find me the general. So because they said so, I can now say, okay, well, if they said so, then it's fine. That is my second difference, and that is my first difference, which you don't have to write there. And then to get to our answers, we'll say 2a equals 3a plus b equals a plus b plus c equals. Stick to the pattern, guys. Everybody likes a good pattern that always works. So this is step 1, 2, 3, because of good reasons. There's 1 variable to solve, there's 2 variables to solve, there's 3. So for step number 1, a works out to be 7/2. Step number 2, 3a plus b is equal to -4. Remember the first one. 3 times 7/2 plus b. Please remember that this is multiplication. This is not 3 and 7/2. And then you'll get your answer of, how much is that?
-29/2.
Okay, just double check yourself always. And then a plus b plus c is equal to 3. So a was 7/2. B was -29/2. C is what I'm looking for, and my C worked out to be
14.
Okay, fantastic. 14. Thank you. All right. Finished?
No.
No, they asked me for the general term. So your general term would be a n squared plus b n plus c 14. Because everything else is now built upon this. Next question says which term will be equal to. So this pattern is continuing somewhere. This will be the pattern. What do I do?
Then b is -29/2.
Oh, did I write? Where did I get this 4 from? I got it here. Thank you very much. Minus 29 over 2. Because that would not have made my sum work. I would have gone here and n was worth, oh, I don't know what. And what would you say about that? There can't be a solution. There cannot be such a number in that number pattern that I've got there. Are you with me? Then at least the logic is there, though you made a crucial mistake. Thank you. So we take our equation, 7 over 2 n squared minus, that expression is now an equation. That's the expression to work out terms. This is now an equation, and again, what's the rules? Get it equal to 0. If you want to first do that, that's fine. And then sort out the fact that you've got fractions galore here. Or first do the fractions and then get it equal to 0. But you're going to get a mark for putting it equal to 0 correctly. So whether you do it first or last, taking across that number there, which will be minus
1H25.
okay, equal to 0. I'm not going to give you a mark for that because that's all part of the getting it into the correct form, into standard form. Then if you times the whole thing by 2, what will this be?
3650.
Alright, now good luck if you want to do it the old-fashioned way. 1 times 7, okay, like this. 1 times 3,600, 2 times 1,800, 3 times, 4 times 5, oh, good luck. You with me? That's actually how you're supposed to do it. So the better thing then, if you don't have the new calculator that I was promoting to you, is to then do the formula. And it's still an option. It takes longer than going to the calculator and now saying A is 7, B, and C, and getting your actual answers. So the answers were, please?
25 or negative 20,86.
Okay, give it to me in fraction form, please.
146 over 7.
Over 7. Because now, if the calculator gave it to me like this, I don't want it in decimals. I want it this way, because now you've got to crook it right. The markers want to see the factors. Now the calculator is directly giving you the answers. You've got to know now how to put it back in there. This one's not difficult. Agreed with me? But then what should this have been? So you'll take the 7, leave the minus, B. Take the 7 and time it to the other side, so you'll have 7n. But then the minus 142 will become a, 146. Is it true? 146 on the other side is negative and divided by 7. So it's just something to get used to. That's why you don't get the new calculator the day before you write. You've got to be able to go practice. And again, a mark is lost because I didn't say. That cannot happen. Alright, can't be a negative and it can't be a fraction. Has to be that one. So term number 25 would have been equal to that number. Right. Okay. Now, if I want to talk about maximum and minimum terms, obviously there's your quadratic pattern is going. Some of them only start somewhere and go more all the time. Because it can be that they only took one part of the left-hand side of the, let me say it was a smiley face, but they only used this piece here. Then they'll only grow. But most of those terms have go lesser and then go more again. Because it's quadratic, it's a parabola. Or will go more and be a maximum and then go less again. So now back to parabolas. How do I find the maximum and the minimum value if I have a parabola? Now, first of all, I didn't do the sum again. You can please go and check yourself on this. Please go and find the general term. There it is. I checked it was correct. That it was term number, not the general term was n squared, so A was 1, B was negative 42, and C was 440. I'm not going to do it again. We're saving some time. If I then ask you, please tell me which term will be the minimum value in that whole quadratic number pattern. How do I find a minimum and a maximum value? You can still remember. How do I find a minimum or a maximum?
The minimum
Completing the square. When we were busy with the parabolas as well, and we said what would be the maximums and the minimums, that's where we did it. So, completing the square. That's not the only way, I'll show you now. But I want to remind you of this, you have a test coming up. So, if I want to find the minimum or the maximum of n squared minus 42n plus 440, and I want to do completing the square, which is one of the techniques, how does it work? Please remember that this is Tn. It's not an equation, it's an expression. So you can't time both sides and whatever. That is now the expression. So if I want to find completing the square so that I can put it into turning point form, remember? What are the methods? What is the technique? First of all, this has to be a 1, which luckily for us it was. If it wasn't, you can't take the 2 or whatever there is just away because it's not an equation. It's got to stay there and remember the techniques. Then if this is a 1, you take the coefficient of n, which is? 42. Negative 42. What do you do with the negative 42? Times a half. Times a half? And square it. Please give me an answer. Yes? 441. What do I do with this 441? Guys, what are we busy with here? So we need the number to complete this 3 term here to make it a complete square. Are you getting back 7 months ago from this? So you need that number, that plus 441 that you got on a very specific technique to make it a complete square, getting it there. But then you can't just add something to the sum. You must make it legal. Because remember, sometimes there were brackets and it looked like we were adding something and adding something again. Make it legal. This is definitely still the original sum. Please don't go and add them all up again and get back to where you were. This 3 term here will now make up a perfect square, which we did by saying the first one square rooted is n. The second one's sign was negative. And then that one square rooted was? 21. Alright? And then we add these 2 together and they give me negative 1. Now those of you who do have the new calculator, if you go to your calculator and punch in negative 1 for the A, negative 42 for the B, and 440 for the C. And you're asking for the x values. The x values would have been 20 and 22. I remember it from previously, not just that I know it. Those would have been your x-intercepts. I'm not asking for that. But a minimum value of a parabola will be by the turning point. But if the x-intercepts are at 20 and 22, where's the turning point? 21. Where's the turning point? Because if you write it in completed square formation, this is turning point form. That would be your turning point. Now, the fantastic thing about the calculator is it'll give you first your x-intercepts, which I don't need for this technique. But then it will also, if you press the button again, it'll also tell you that the minimum, well, this one will be a minimum value. Minimum value of x will be where x is 21. And then the y value for that minimum they told you was negative 1. Basically telling you that the turning point is, fantastic calculator. What's happening here? It's exactly the same thing. Please answer the question. My question was, which term will be a minimum value? It'll be term number 21 and the minimum value is negative 1. So term number 21's value would be negative 1. If this had been a normal parabola, that would have been an x, the turning point would have been 21 and negative 1. So it means if x is 21, the y value would be negative 1. But now remember, this is Tn. So if n is 21, the y value or the Tn would be negative. That was my question. Which term will have a minimum value? So term 21 would have the minimum value. They never asked me what it was, but I can see it is negative 1. Okay. But man, can't I do it in a different way? Absolutely. I just wanted to remind you of completing the square. And normally in grade 11, if they say maximum or minimum, it's completing the square. If you want to have a fail-safe, it's completing the square. But couldn't I have worked out the turning point by doing x is equal to negative b over 2a?
Yes.
Absolutely. And what would that x have been? And then with that x value, go back again. Okay, now remember it's n. The value then would have worked out to negative 1 again. But if you know that the turning point is at 21, now think about it. If the turning of the x, if the turning point is at 21, that's the value that will have a minimum value. Because this was a positive graph, so it has a minimum value. Alright, so there's many ways of doing it, and I cannot say that is the only thing that's right. You cannot work with x-intercepts and the turning point in between. Think about it. If the two x-intercepts are 22 and 22, 20 and 22, where's the turning point? That's a completely different technique, is it right? 100%. 100% if you knew what you were doing. Last question for today. If I give you a quadratic number pattern, and I have to tell you that this is a quadratic number pattern because how will you know what it is? If there's an x floating about, you knew it was coming. What do you do if I tell you that it is quadratic? Always. Right? Always. So what do we do?
7 minus
7 minus 1 is?
6. X minus 6.
Aha. X minus 7. That's it. And here?
31 minus 6.
Not x minus 31. It's so important. That's the reason why I was keeping on that same old hall. It has to be the fourth one minus the third one minus the second one, etc. Okay, so that's my first difference. Now what about the second difference?
So you say x minus 7.
X minus 7 minus 6, which we are going to simplify. Are you with me with the technique? X minus 7 minus 6. And here? 31 minus x minus bracket. I love it. If you don't have the bracket, it's wrong. Because it's this one minus the whole thing, even if there's 2, 3, 4, 5 terms. It's minus the whole thing in brackets. So eventually I'm going to speed you up and say, well, you know that negative, when you say minus, this is always going to change all the signs. So this will become minus and plus. Yes, it will become minus and plus. Are you with me? So you can speed up a little bit. But the question was find x.
You make them equal this.
Why would you make them equal?
Because they're equal.
Second difference.
Because they told me that this was a quadratic number pattern, so the mark that you're going to get is for saying
Equal.
for knowing that the second differences are equal. And that's how I'm going to solve my x. Normally something like this would be 1 mark for doing the first difference is correct, 1 mark for doing the second difference is correct, and a mark for putting them equal to each other, knowing that you must do that. Now what type of a sum is this? Linear. How easy peasy is that? So get the x's to one side, however you want to go do it. 51 if I'm correct. And divide by 3 gives me 17. And that's it. So this sum would have been something like 4 marks. Now, can I not go again? Please don't overdo a sum. That's it. The question was get x, I've done x, that's it. Can I not go 1, 7, 10, 31? Actually get the numbers 17, sorry. 10 and 14. So that the second differences were 4. And there we go. Find the general term. You are wasting your time. I never asked you for that. But it does work out. Are you with me? I just asked you for x. Alright. Homework? Please try number B. Number B looks like this, but it's got a Y also. Please try. So don't take a day. 15 minutes.